Lesson 5.3 is titled Slope-Intercept Form of a Linear Equation. So our goals today are to write in slope-intercept form. So here's an example of what we might see. Minnesota Vikings running back Adrian Peterson makes $2.4 million a year to play football. When he signed his most recent contract, he also received $500,000 as a signing bonus. Write an equation and make a graph of the situation. This is a linear situation we will solve later in the lesson, but this could be written in slope-intercept form. So relating it to the real world, we have two letters we're going to be dealing with today. Our y-intercept is our b value, and our slope is our m. The equation we're working with is y equals mx plus b. So reading the question, it says, bamboo can grow very quickly. The graph models the growth of a bamboo plant. Find the point where the line crosses the vertical axis. What does this point tell you about the bamboo plant? So here's the vertical axis and where it starts. So it starts at 20. So before the bamboo starts to grow, it starts at a height of 20 feet. So its y-intercept is 20. What does this tell you about the bamboo plant? Well, that's the height at which it starts. Then find the slope of the line. What does the slope tell you about the bamboo plant? How do you know? So if I compare this dot at 0 to a dot at 10, what was my increase? So the point 020 is our first point, and then we have the point 1030. So we want to decide how much did we increase by. So it looks like we went up 10 to 30, and then we went over 10. So our rise is 10, and our run is also 10. So notice our scale on the y-axis is jumping by 10. The scale on the y-axis is jumping by 5. So then we jumped up 10 over 10, so that gives us a slope of 1. So every day the bamboo grows 1 foot. So the equation would be y equals 1x plus 20, which we would also write as y equals x plus 20, because 1x and x are the same thing. So a family of functions is a group of functions that have similar characteristics. We had the quadratics, the linears, the cubics. Remember, I think we called quadratics a cup, the linears a line, and then the cubics we called a curve, or they call it a snake. A parent function is what we started with, so we have y equals x for the most part today. This was our cup, and this was our swirl. And the linear parent function is just y equals x. So what we're going to be doing is just changing our m and our b. So we really have y equals mx plus b. So a linear equation is an equation that models a linear function. So y equals 2x, y equals negative 1/2 x, y equals 1/2 x plus 3. And then these are the non-linear examples. So 3 to the power of x, x squared, x cubed. So notice it just has to have an x all by itself. So whenever you have linear, you should have a straight line. And we'll talk more about these ideas in some of the upcoming lessons. But today we're mainly just focused on y equals mx plus b. So the y-intercept is the y-coordinate where the graph crosses the y-axis. So if we look at these points here, I'm crossing at 0 and I'm crossing at negative 3. And then we use those to find our b value. So super key concept. We will use slope-intercept form to help us graph a linear equation quickly. So m is our slope, b is our y-intercept. So let's go through these, identifying the slope and y-intercept. So in number 1, our m value is 3 and our b value is 4. And we're just coming from that general equation, y equals mx plus b. So in number 2, write down what you think. In number 3, write down what you think. So in number 2, your m should have been negative 1/3. And your b should have been negative 2. And number 3 is one of those trickier questions where we just have to do a little work. So you should be saying, oh, y is not by itself. So we have to make it look like y equals mx plus b. So we're going to subtract 2x. So then we get y equals negative 2x plus 4. And now we can see our m is negative 2 and our b value is 4. So first you had to have y by itself before you could find your m and your b. So writing a linear equation in slope-intercept form. So here's y equals mx plus b. What two letters in the equation above will we replace every time? Well, we're going to find something for the m and something for the b, but the y and the x should always be there. So you always want to have a space for the slope and a space for the y-intercept. So example 2, it says, write an equation in slope-intercept form given the slope and the y-intercept. So we know y equals mx plus b. So number 1, y equals 2x plus 9. Number 2, y equals negative 3/4 x minus 5. And we'll skip this. Example 3, write an equation in slope-intercept form of a line shown. Well, we have to figure out what is our m and what is our b. So let's look for our b first, because that's a little easier. So I see it crosses at what number? 2. So b is equal to 2, and now we're looking for our m. M, like we said the other day, is rise over run, and you always read graphs from left to right. So from that dot to the next dot, or I could have used this dot or this dot, I have to figure out what is my rise and my run. So rise, I'm going down 1, forward 1. So down 1 is negative, and forward 1 is positive. So our m value is negative 1. So our linear equation is y equals negative 1x plus 2, and more specifically, it is negative x plus 2. So what we can do is check these 2 points. If I plug in 0, I get 2, and if I plug in 1, I should also get 1. So yes, those 2 points work. And you can always check any point, so that's where we got them. Here is 0, 2 right here, and then here is 1, 1. You can check to see if your equation matches. So here is our solution. Let's see if you got it. Write an equation, slope-intercept form of the line shown. So why don't you take a minute or two and figure out what's going on. You want to probably pick some points first. I would try to pick integers, whereas if I put a dot here, that would be at a decimal or a fraction at 1.5. So you should be working on those right now. All right, number 1. Our b value is easier to find because it's just looking at a value. Where does it cross the y-axis? At negative 2. Then we're looking for our slope. So that's rise. So I'm going up 2, and then I'm going forward 1. Up 2, forward 1. So that's over 2, up 1, which is 2. So our answer, our equation, is y equals 2x minus 2. Number 2, our m, we're going up 2 over 1, 2, 3. So that was 2 over 3. We check another one, up 2 over 3. And notice this would be a positive slope because we'd be climbing from left to right uphill. So that should be positive. And our b value is at 1. So your equation for number 2 is y equals 2/3 x plus 1. Number 3 is a challenge question, and we'll talk more about this when I get back. So this is the y-axis, this is an x-axis. So these little tick marks, that's a 1, a 2, and a 3. This is a horizontal line, so all of the y values on this line are equal to negative 3, so this would be your equation. So whenever you have just a horizontal or a vertical line, your equation isn't going to be y equals mx plus b. So if we analyze this, our m, notice how we're not rising, but we're running 1. So our slope here is 0. So we'd be going up 0, going forward 1 or 2 or whatever. It didn't matter. So that's our slope. And our b value is -3. So that's why we have y equals -3, because our slope is 0. So, as of now, what are two things we need to have for an equation of a line? We need an m, and we need a b. So we need an m, and we need a b. So what is the equation in slope-intercept form that passes through these 2 points? So let's find our m. So our formula is y2 minus y1, change in y, over change in x. So 12 minus 9 over 5 minus 2. So I get 3 over 3, which is 1. So that's my m. So I also could have went 9 over minus 12, 2 minus 5, but I tried to make it so that it was a positive number. Then we have to find our b value. So we're going to go in the form y equals mx plus b. And let's pick a point. I'm going to pick the first point because it has smaller numbers. So this is my x, and this is my y. So if y is 9, my m we found above to be 1, and our x is 2, and b is what we're trying to figure out. So I can plug and chug. 9 equals 2 plus b. So I have 7 for b because I subtracted 2. So now I know what my m is. And now I know what my b is, so I can write my equation. Let's try another one. So, slope-intercept form. So I need an m and a b. So we need to find our m first. So I want to go 6 minus 3 over 4 minus 2. So that's 3 over 2. Then I want to pick a point. I'm going to pick the first point just because the numbers are lower than having a 4 and a 6. And we're plugging in for y equals mx plus b. So this is my x, and this is my y. So I get 3 equals 3/2 times 2 plus b. Simplify. This is really 2 over 1, so the 2's are going to cancel, and we get 3. So if I subtract 3, I get 0. So writing my equation, I get y equals 3/2 x plus 0, so I'm not going to write the plus 0. You try number 2. So you should be getting y equals 2x plus 8. The other thing you want to notice is look at this point right here, 0, 8. If you graphed that, that would actually be your y-intercept. So it would cross at 8. So notice how it is, the b value is an 8. So we could have skipped everything from there to there. Once we had our slope, we knew that this had to be an 8 because this is our y-intercept because this number is a 0. So if that happens, you do have a shortcut. And number 3 we'll go through. So you want to do rise over run. So I'm going to do 4 minus a minus 5, a -1 minus 4. So that gives us 9 over -5. Pick a point. So that's y equals mx plus b. So we have 4 equals -1 times -9/5 plus b. So So 4 equals 9/5 plus b, subtract, and this will give you 11/5 for b. So then y equals negative 9/5 x plus 11/5. And normally I won't give you two fractions in the answer type question.